This video is for section 7-7, products of sums containing radicals. We're going to review skills that we've used in the past, such as the distributive property or FOIL. It's just that our questions will have radicals in them. When you have problems like this, it's necessary to put them in simplest form, to simplify them. So we want to make sure we follow the different requirements for simplified radicals. That we don't have fractions in a radical, that we don't leave a radical in the denominator, and so on. For this first example problem, here's our question. Do you recognize the pattern of this? This first thing here in parentheses is called a binomial, and the second thing in parentheses is called a binomial. That's when you use FOIL, first, outer, inner, last. So just take it step by step. 2 times the square root of 6 makes 2 square root of 6. Now do the letter O, that's your outer. So the 2 out here times the square root of 2 over here. 2 times negative square root of 2 makes negative 2 square root of 2. Notice how to multiply a regular number to a radical. You just write them side by side. Now the letter I in FOIL, the inner. So let's take this term and times to this term. Negative square root of 3 times the square root of 6 makes negative square root of 18. I'm timesing the numbers in the radicals to create an 18 in the radical. Now the letter L in FOIL. That's when you take the last thing in the first parentheses and multiply to the last thing in the second parentheses. Negative times negative makes a plus sign, and square root of 3 times square root of 2 makes square root of 6. So multiplying with FOIL, we get these 4 terms. Now we need to simplify this farther. As I look across here, there's nothing to do with the square root of 6 or the square root of 2, but the square root of 18 can be simplified if we think of 18 as 9 times 2. So let's rewrite a lot of the question, but when we get to the square root of 18, think of that as the square root of 9 times 2. And then the thing on the end, just write it down as well. Next up, we're going to rewrite a lot of the question, but when we get to this part here, we can make a replacement because the square root of 9 is just a 3. So we get the minus and then a 3. This 2 stays in the radical. We're almost done. We can't simplify anymore in the individual terms themselves, but we can combine like terms because we have some like radicals. This radical has a square root of 6. Later on there's another square root of 6. Those are called like terms. So 2 square root of 6 plus 1 square root of 6 makes 3 square root of 6. And this one and this one are like terms. They both have a square root of 2 in them, so we can combine. Negative 2 minus 3 makes negative 5 square root of 2. This is just like combining variables. It's just that they're radical symbols instead of letters such as X or something. For our next example, we're asked to rationalize the denominator. The denominator of this fraction has radicals in it. And that's not simple form when there's radicals in the bottom. So we're going to use a technique called rationalizing. The way that you do this is to multiply top and bottom by the conjugate. The conjugate of the denominator will be the same 2 terms, but with the opposite sign in the middle. So multiply the top by 2 square root of 7 plus the square root of 10. And multiply the bottom by that same thing. Remember, as long as you multiply a fraction top and bottom by the same thing, you're not changing the overall value of the fraction. I'm going to also put parentheses around this right here to help me do FOIL in the next step. Okay, in the top, let's multiply the 3 to that binomial by doing the distributive property. 3 times 2 square root of 7 makes 6 square root of 7. And 3 times square root of 10 makes 3 square root of 10. Again, to multiply a number to a radical, you're multiplying the normal numbers together and just writing the radical next to it. Down in the denominator, let's use FOIL. But before we do that, I want to point out something. This is that special case of FOIL that we've had before, where all the terms match each other, but this is a minus and this is a plus. We don't have to do the outer and inner products because they're going to cancel each other away anyway. So let's only do the letter F and the letter L in the word FOIL. 2 square root of 7 multiplied to that 2 square root of 7 makes 4 times the square root of 49. I'm taking the regular numbers that are out front, 2 times 2, getting the 4. And in the radical, I'm taking the 7 times 7, getting a 49. Next, we'll do the letter L in the word FOIL. So negative times positive makes a minus sign, and square root of 10 times square root of 10 makes square root of 100. But isn't the square root of 100 really just 10? Right here, isn't the square root of 49 really just a 7? So that's our next step. Let's write the top down and do some simplifying in the denominator. The square root of 49 is just a 7, and 4 times 7 is 28. Right in this spot, the square root of 100 is just a 10. All right, next step. Let's copy the top down again. And in the denominator, 28 take away 10 is 18. Is there any reducing? 6 and 18 will reduce, and 3 and 18 will reduce. So let's do that. 6 over 18 reduces to 1 over 3, and 3 over 18 reduces to a 1 over a 6. I'm not actually writing a 1 up in the top in front of that. And when I said that 6 over 18 reduced to 1 over 3, I didn't actually write the 1 here because I already had something to be in the top. So here is our simplified version of the answer. By using irrational numbers, that's the numbers that have radicals around them, we can expand the set of polynomials that we're able to factor. For example, earlier this year when we were studying factoring, when we had x squared minus 8, we were not able to factor that. But now we can factor that. Let's try that in this example. X squared minus 8 fits the difference of squares pattern. On the yellow poster on the wall and on the note pages that I've given you this year, it was a squared minus b squared. That was the general pattern. And you were expected to factor that with 2 sets of parentheses, getting a plus b and a minus b. Our question, x squared minus 8, fits that pattern. So it will make 2 sets of parentheses. Now what goes here and here? It's x times x, because that's what makes x squared. Now for this to be a minus sign, we have to have plus and minus. Now what goes here and here? Remember, they have to times together to make 8. So because we now know about irrational numbers, we can get the values. Square root of 8 times square root of 8. If you multiply those, that makes an 8. Again, you're used to factoring differences of squares where it works out to use rational numbers. This example makes x plus 3 times x minus 3. You haven't had as much practice factoring something like this. It is totally the same pattern, and you can still factor it. It's just you have to use radicals. You would use square root of 11 and over here, square root of 11. Do you notice the connection between these? It is the same skill. Let's summarize the lesson. We started by practicing how to simplify products, meaning multiplication problems that involve radicals. Then we practiced rationalizing the denominator. The technique is to multiply top and bottom by the conjugate of the denominator. Finally, we factored something that we were not able to factor earlier this year, but if you use square root symbols, now we can factor.